Go.
So today we're going to talk about what information we can find off of the periodic table about our atoms and their subatomic particles. So if we were given a particular element on the periodic table like this one here, we can find some information right away. So the first thing we can know is that this right here would be the element symbol, the W. So that stands for tungsten for its element symbol. We also have the atomic number, which is 74. Okay, and then we also have the mass number over here, 183.85. So given the information about atomic number and mass number and the element symbol off of the periodic table, we can use it to find the number of protons, the number of neutrons, and the number of electrons. But make sure we understand that for here, we're talking about a neutral atom. So a couple of the key equations needed to calculate the number of protons, neutrons, and electrons in an atom include the following. So first up, we have protons equals the number of neutrons for a neutral atom. Then we have the number of protons added with the number of neutrons, and that gives you the mass number that we found on the periodic table. And then we have that the number of protons comes from your atomic number on the periodic table. So if I wanted to find the number of protons, neutrons, and electrons for a neutral atom of tungsten, I would have to use my key equations. So the easiest one to determine would be the number of protons. It's just the atomic number, and so for tungsten, that would be just 74. The number of electrons in a neutral atom is equal to the number of protons, so for tungsten, it would also be 74 electrons. So the hardest one to find would be the number of neutrons, and that's because you have a complicated equation with that one. You have that the number of protons plus the number of neutrons equals the mass number. So to find the number of neutrons, you would have to rearrange the equation so that it looks like this, where the number of neutrons equals the mass number minus the number of protons. So for tungsten, that would be 184 for their mass number rounded, minus 74 equals 110 neutrons for tungsten in that nucleus. So our periodic table tells us information about our elements, but there's also two other ways that are used to tell us different informations about the subatomic particles. The first way is called symbol notation, where you have the mass number put on the top left-hand side of the symbol. The atomic number is put on the the bottom left-hand side of the symbol, and then your charge, whether it's neutral or has a positive or negative charge, is put on the top right side of the symbol, which goes in the middle in big letters. So this is one way to give information about the subatomic particles. You also have something called hyphen notation, where you have the element name right here, and then you have the mass number that goes with it after that. Okay. So hyphen notation is how we express a lot of our things called isotopes. So isotopes are atoms that have the same equal number of protons but different number of neutrons. So the key idea here is that they're still the same element. They just have different number of neutrons but they still have the same number of protons. Two examples of isotopes are uranium-238 and uranium-235. They're used in nuclear energy, which we're going to talk about next in chapter 25. Uranium-235 with atomic number of 92 is radioactive by itself, just that atom with that mass number by itself. But uranium-238 kind of goes through a decay process, becomes plutonium-239, and in that way, or in that decay process, it absorbs neutrons and that becomes radioactive. So we can use that as energy. So you're probably wondering why your mass number on the periodic table has a decimal. Where did that decimal come from? And if mass numbers can be different in nature because of isotopes. So where it came from was really an average of all the known isotopes in nature. So they take all the known isotopes, find the average of them, and then use that number to put on the periodic table. So to find the average and to put that on your periodic table, we use the equation to find the average atomic mass, and that is as follows. The mass of isotope number 1 times its relative abundance in nature plus the mass of isotope number 2 times its relative abundance in nature plus any other isotopes that occur times their relative abundances in nature. So let's do an example problem. Let's say we had carbon 12 and has a relative abundance of 98.89%, and carbon 13 has a relative abundance of 1.11%. And we wanted to find the average atomic mass of this. So the average atomic mass, again, would be the mass of isotope number 1, the mass number, times its relative abundance, added with the mass of isotope number 2, carbon 13 in this case, times its relative abundance. So the average atomic mass would then equal to 12 for the atomic number or mass number of carbon 12 times 0.9889, which was our decimal for relative abundance percentage, plus 13, the mass number of the other isotope, times 0.0111, our percentage for relative abundance converted to a decimal again. We would then get 11.867 plus 0.144, and together that would be 12.011 atomic mass units. That's the unit for the average atomic mass. So, hope you learned something today about finding the number of protons, electrons, and neutrons. I want to remind you of the key equations that we had and how they are used for finding the number of protons, electrons, and neutrons. So protons equals the number of electrons in a neutral atom. Protons plus the number of neutrons equals the mass number found on the periodic table, and the number of protons comes from the atomic number also found on the periodic table. Hope you have a wonderful night. I'll see you all tomorrow.